Hello children, today we will start a new topic called relations. So in real life we have got many relations like A is a father of B, C is a daughter of D, a relation between a teacher and a student, right? So we have got number of relations in real life. Similarly in mathematics also we have got relations like A is parallel to B or A is less than B if they are points, right? And if they are subsets we can say that A is a subset of B, right? So in maths also we have got many relations. So the very first topic in relations is the Cartesian product. We should know what is a Cartesian product of two sets. So let us say we have got a set A which has got three elements which are H, M, T, and in set B we have got elements as Honda, Maruti and Toyota. So the Cartesian product of A and B is the pair of all objects from A to B. So if I list down all the pair of objects starting from A, so the first element is A and the second element is from B. So if the visual representation of the Cartesian product I have shown, we can draw like this, the first element from A, because it is a Cartesian product of A and B, A cross B, right? So it is also known as the cross product of A and B. So the first element from A, take the first element H, and the first element from B becomes the first pair. So H comma Honda. Then with the first object of A and the second from B, H comma Maruti, and then H comma Toyota. Then take the second element from A, M comma Honda, then M comma Maruti, and then M comma Toyota. And then similarly the third element from A, T comma Honda, T comma Maruti, and then T comma Toyota. So these all are the pair of objects that I can make from two sets A and B. And if I enclose these in sets, all the pairs are enclosed in a set, then this whole set consisting of all these pair of objects is known as the Cartesian product of A and B. So we can write in set builder form the Cartesian product. We can also write in set builder form, right? Which can be written as A cross B can be written as the A cross B is the set of all pair of objects x, y such that x belongs to set A and y belongs to set B. So these x, y, A, B can be anything, right? So this is the Cartesian product in set builder form. Now the pairs, these are the 9 pairs which I have written over here. These pairs also represent the position of basically points in the Cartesian plane. So basically we can also plot these points in the Cartesian plane and they have some positions. Each pair represents a position of point basically in the Cartesian plane. So we can draw these in Cartesian plane. Let us say that this is a Cartesian plane and this is point H. So if this is set A, this is set A and this is set B, then these are the elements HMT and these are the elements of B, Honda, and then Maruti, in the same Maruti, and then Toyota, right? Toyota. So this particular point is H comma Honda. This particular point is M comma Honda. This particular point is T comma Honda. So this is H comma Maruti. This is T comma Toyota. This is M comma Maruti, M comma Toyota, T comma Maruti and T comma Toyota. So see these are the 9 points which I have plotted in the Cartesian plane. So each pair basically represents the position of a point in a Cartesian plane, right? So we will now see what are the properties of Cartesian product A cross B. So the order of the pair. So let us say we have got two pairs 1 comma 2 and 2 comma 1. So are these same or are these different? So basically the order of the elements in the Cartesian pair are very important. So if I plot 1 comma 2 in a Cartesian plane, the position will be, this is, if this is 1 and this is 2, so this is 1 comma 2, right? This is 1 comma 2, and if I have to plot 2 comma 1, then it will be, this is 2, this is 1, so this will be 2 comma 1. So you see, these two pairs are two different points in the Cartesian plane, therefore these two pairs are different. So we say that the order of elements in the elements in this pair is very important. Now the two order pairs are these, if we have got two order pairs like x, y and a and b, so in what condition they can be equal? They can be equal if x is equal to a, that means the first element of both the pairs are same and the second element is also same. If the second element of both the pairs are same, then we say that two order pairs are same, are equal, right? Now, how many number of ordered pairs can I make from two sets? Now let us say I have got two, in the above example, in the above example, my NA was 3. NA means the total number of elements in A, this is 3, and my total number of elements in B was also 3. So I have got 9 different pairs in my Cartesian product. So that means if we want to write the general formula for this, then we say if NA is equal to M and NB is equal to N, then we write N of A cross B will have M cross N elements, right? M cross, we should not write M cross N, we should write MN elements, right? So over there in the example, it was the product of 3 and 3, which was 9, right? So this is a general formula of the total number of elements in the Cartesian product. Now the fourth property, if either A or B is void set or null set or empty set, then what is the Cartesian product? A cross B. So if any of A or B is phi, then my Cartesian product will also be phi, correct? It will also be a null set. Similarly, if A or B is infinite, the fifth property says if A or B is infinite set, then what will happen to my Cartesian product? Yes, if any of A or B is infinite, we will say that my Cartesian product will also be a infinite set, right? So if we have two sets, A is a natural number and B is a set of whole numbers, then my Cartesian product will also be a set, an infinite set, right? Or if any one of this is infinite, my Cartesian product will be infinite, right? Now we have one more thing, term called ordered triplet. What is an ordered triplet? If I have got A cross A cross A, like this type of Cartesian product, so I have got A B C, where A B C, everything A B C belongs to A, right? In that case my ABC will be known as the ordered triplet. So it is just a term we should know. Somewhere in the example, if it is written my ordered triplet is ABC, then we should know that all the three ABC belongs to A, right? Now the seventh property is that the Cartesian product is non-commutative. Non-commutative means, let us say I have got two sets A and B. I have got two non-empty sets basically. So A cross B will not be equal to B cross A. Will not be equal to B cross A. They will only be equal if in case A cross B is equal to B cross A. That means that so if this is the case, this is true only if A is equal to B. If both the sets are equal, then we will say that yes, A cross B is equal to B cross A, or in case A or B is phi. So in that case, both will be the null set. So in that case also we will say that both A cross B and B cross A are same, correct? So otherwise, if these two are different sets, then this is the property that A cross B is not equal to B cross A, right? Similarly, the Cartesian product is non-associative. The eighth property says that Cartesian product is non-associative It means that A cross B cross C, if I've got three non-empty sets, A cross B cross C will not be equal to A cross B cross C. In this case, you can just take a simple example. Let us say I have got A as 1, B as 2 and C as 3. Let us say this thing. Then first do A cross B. It will be an order pair 1 comma 2, and now A cross B cross C will be my set containing the element like this 1 comma 2 comma 3. Right? Agree? So this is my element in A cross B cross C. Now if I have to have A cross B cross C, so this will be, what will be my B cross C? It will be 2 comma 3, and my A cross this thing will be it will be 1 order pair 1 comma 2 comma 3. So you see that these are the two different points, 1 comma 2 we will plot, and then we will plot this thing comma 3, and then this thing. So basically this is an this is a 3D plane, right? Like this, A B C. So like this. So again we will say that these 2 points are not same. So the Cartesian product is non-associative, right? Now the ninth property says that the Cartesian product is distributive over intersection of sets, right? So that means if I have got 3 sets A, B and C, then we will say that A intersection of B cross C will be equal to A intersection B cross A intersection C, like this. So it is distributive over intersection of sets, right? So it is a simple property. You can just take 3 sets and you will just do first this and then the intersection of this, and then in the second case you do the intersection of 2 sets and take the cross product. Both will come out to be same, right? Now distributive over union of sets. It is again the similar thing. A union, if we have got 3 non-empty sets, then A union B cross C will be equal to A union B union of A in A cross B union A cross C. Okay? So like this. Now we will just take simple problems on the Cartesian product. Let A and B are given. Write down A cross B. It is very simple. First element, so A cross B will be, the first element of A is 1, second element of B is 3, so 1 comma 3. Now first element of 1, second element of B 4. Now the second element of A 2 and the first element of B, and the second element of A and the second element of B. So these are the ordered pairs in the Cartesian product. 4 ordered pairs, है ना? अब now it has been asked how many subsets will A cross B have. This is why, how many subsets will A cross B have? List them. So if we want to write the formula, see, each pair will have 2 choices. Either we can take it or we will not take it. This pair also have 2 choices. Either we can take it or we will not take it. This pair also has 2 choices. Either we can take it or we will not take it. Again, this has 2 choices. Either we take it or we will not take it. So the total number of subsets that can be made out of from A cross B will be the multiplication of these numbers, and it comes out to be 2 raised to power 4, which is 16. So if we generalize, so let us say NA is, the number of elements in A is P, and number of, or we will write it the way the variable which have been used before, M, NA is M, and let us say NB is N, then my NA cross B, the total number of elements in A cross B will be M into N, right? And now the total number of subsets. So the total number of subsets which we can make from these number of pair of elements will be 2 raised to power M N, total subsets. Now they have also ask me to list them, so you can easily list them, the total number of subsets. So one subset will be 1 comma 3, this is my one subset, right? The second subset will be if I take 1 comma 3 and if I will take 1 comma 4, right? So all the permutation and combination of the sets, so 16 such subsets will be there. Out of 16, one subset will be 5 and one will be the complete set containing all the four pairs, which will be A cross A. So one will be the phi set and one will be the universal set, right? Sorry, A cross B. This will be A cross B, the complete set A cross B, right? So in this way you can list down all the 16 elements, right? So now let us see the second question. Yes, this is the second question. Let A and B are two sets such that NA is equal to 3 and NB equal to 2. If x1, y2, z1 are in A cross B, find A and B, where x and y and z are the distinct elements. Now it is given that NA is 3, so that means we have set A which has got 3 elements in it, and we have got set B which has got 2 elements in it, right? Now we have to find A and B, where they have written that A cross B has, if A cross B will have how many pair of elements? It will be having six pairs, right? It will have 6 pairs, 1 2 3 4 5 and 6. Now out of these 6 elements, 3 are given to us. What are those 3? X1 is given, Y2 is given and Z1 is given, right? So clearly we can say that the first element of the order pair will be from set A, right? So we have got 3 distinct elements from there, X, Y, Z. So X, Y, Z are the 3 elements we have found, right? It is easy. The second element will be from B. So clearly we can see there are 1 and 2 are the 2 distinct elements in these pair. So the element of B will be 1 and 2. And now from these sets we can easily find out the remaining pair of elements, remaining pairs, right? Now we will come to the next question. The Cartesian product A cross A has got 9 elements, among which are found minus 1 comma 0 and 0 comma 1. Find the set A and the remaining elements of A cross A. So I have got A as one of the element, and we have found A cross A has got 9 elements. So that means it is 3 square. So that means NA is 3, right? So that means A has got 3 elements in it. And in those Cartesian product, if we write the Cartesian product of A cross A, then we have found that out of these 9 elements, we have found that minus 1 comma 0 and 0 comma 1 are its elements, right? So can you see that minus 1 also belongs, the first element also belongs to A over here, and the second element will also belongs to A, because both sets are A. So we have got, since NA is 3, clearly we can see that I have got minus 1, 0 and 1 as the elements of A. So elements of A are minus 1, 0 and 1. Clear? So we have found set A, and with this set A you just find out the cross product of A cross A and A, and then you can find out the remaining elements of the cross product A of A, right? So like this, these were very simple questions of the Cartesian product. In the next video we will start with the introduction of relations, and then we will see some more questions on relations. So till then you just revise this concept, and we will meet in the next video.